And with that, I'll turn it over to our host.
Great, thank you. So I'm just going to share a couple of slides initially, just to kind of set the stage for today's conversation. And let me go ahead and do that. And hopefully you see that. And so so again, welcome to this hour of coffee talk. And I'm Mike Jackson. I'm the dean in the College of Science and Technology at Millsville University, and today's program is talking a little bit about that scaffolding of research experiences, and it's part of the CUR transformation project. And with us today we have Brett and Lam, and I'll ask them to do some introductions in just a little bit, so that way they can go ahead and introduce themselves. And I'm one of the consultants on this project, along with actually Beth Cunningham, who just introduced herself earlier in the chat. And what I'd like to do is just talk a little bit, very briefly, about this project before I ask both Lam and Brett to kind of introduce themselves, their institutions, and kind of their interest in it, and then we can open it up to some general Q&A. But just to give you an idea, this project is an NSF-funded project that's led by several individuals within the Council on Undergraduate Research. Typically, it looks like several past presidents, as well as our executive, our current and former executive officer for the Council of Undergraduate Research. And again, the point of this project is to go ahead and integrate and scaffold research into the undergraduate STEM curriculum from first year through senior year at continuous points throughout, basically in a continuum through the curriculum. And before I even delve into that, I just wanted to tell you a little bit about the Council on Undergraduate Research. Again, the mission is to go ahead and support and promote high quality undergraduate research experiences. You can find more information about the organization at cur.org. There's a variety of different programs that individuals can participate in. CUR Posters on the Hill, the National Conference on Undergraduate Research. We have CUR Institutes, which is professional development programs for faculty, as well as the CUR Biennial Conference. It is a professional organization with close to 12,000 individuals. There are disciplines, it's disciplinary oriented. So of course, there's a physics and astronomy division, as well as 10 other divisions beyond that. And there's also multidisciplinary divisions that can also be administrator based, whether it be the at-large or the undergraduate research program directors. And again, the goal of this project is to go ahead and develop a research-rich, intentionally connected scaffolding curriculum. And of course, there are a variety of challenges that are associated with that. And I'm not going to go through all of those, they're here. One of the key ones, especially that many programs and departments have been looking at, especially given light of recent events, is expanding student participation and access to all students, particularly students from traditionally marginalized groups. And so again, the goal of this project is going to be, how institutions are tackling these kind of challenges within their own context and within the context of their department. And again, the goal is to go ahead and find how faculty and students adapt to these changes in the curriculum and the culture that's in order to go ahead and support this. And kind of an infographic to kind of give you an idea of what this is. There are 12 institutions that are participating, 24 departments in all. There are 4 disciplines that are represented here: biology, chemistry, physics, and astronomy, and psychology. The different cohorts meet in an annual, actually semi-annual kind of meetings, multiple meetings within a year. We have monthly conference calls as necessary. There's webinars, and then there's internal kind of components that they're doing within the university, with the goal of having a backward design curriculum that scaffolds research experiences throughout all 4 years. And so that's the point of this program. And I think with that, what I'd like to do is I'd like to go ahead and just turn it on over to basically maybe first Brett, who could go ahead and just introduce himself and maybe talk a little bit, give some context for the institution where Radford University is at.
Okay, thanks, Mike. My name is Brett Taylor. I'm the chair of the physics department at Radford. We're a relatively small state university. As I said in the chat, we're located about 20 minutes from Virginia Tech, and I'm sitting at my house right now and actually can see Virginia Tech from where I'm sitting. So we have about 7,500 undergraduate students at Radford currently. There are a few master's and PhD granting programs at the university, but it's mostly undergraduate, and the department itself is an undergraduate only program. We have 7 faculty lines, one of which is a special purpose line. One is not filled right now, and one of those 2 is shared with chemistry from historical reasons, and we have that faculty member for a third of the time. So she doesn't actually teach any physics courses for us. She teaches a class for some education majors. The department is relatively small. We have 50 to 60 total majors from year to year. And our typical 5-year running average of graduates is about 9 per year. So we're a little above the national average for bachelor's degree only institutions. One of the things that we have going for sort of a recruiting tool is we also have a dual degree program with Virginia Tech's College of Engineering. So they can come to Radford for 2 years, then go to Virginia Tech for 3 years and get a degree at Radford in physics and then some kind of engineering program degree from Virginia Tech. So I guess I should say why we want to do this project. So we were hoping to get students those research skills that we know employers and graduate programs are looking for. But even with our small program, we saw no feasible way to get this done through a peer mentor kind of relationship. We just didn't see how that would be possible. So we thought if we could implement it inside the curriculum, that would save us some time and actually make sure that everybody's getting that opportunity to do that. And one of the reasons we also thought about doing this is we have a lot of retention problems in the first year, particularly for those underrepresented minorities. We get a few women and a few non-white male kind of students every year, but we often lost those in the first semester. So we're hoping through this sort of interaction, especially early on, and getting them involved in the process of doing research, even if it's just a sort of beginning level in an introductory lab, we could make them feel more like physicists and feel more like they could stick around and be successful.
Excellent, thank you. And so maybe with that, I'd like to do a similar kind of introduction for Lam. So Lam, could you go ahead and tell us a little bit about yourself and the Rice University?
So I'm Lam. I'm an assistant teaching professor at Rice. So that's a non-tenure track position, but permanent. So Rice is in Houston. It is a research institution. This undergraduate and graduate population is actually about 50-50, about 5,000 undergraduate, 5,000 graduate students. Physics is probably the largest departments by faculty number on campus, if not the largest, is among the top 3. We have, if you count, we have about, I guess, maybe 30, in the low 30 in the tenure track faculty. If you include all the faculty, including non-tenure track, it will be about 40. The number of major we have between sophomore and senior year, because we don't ask the student to declare until the spring of their sophomore year, is about the same number as Radford, between 40 and 50. So yeah, so we are a very large department, and not the same number of major as the ratio of student to faculty is smaller than Radford. And that would bring me to the motivation for us participating in the CUR transformation project. Is one motivation is just to increase the number of majors, so it'll be, yeah, better than 1-to-1, I guess. But of course, that ratio is not too different than most of our peer institution. But we would like to do better. And another motivation for us participating in the program is that one thing I guess Mike didn't make quite clear is that each institution have 2 departments that participate in the transformation program. So for Rice, it was physics and astronomy and bioscience. And bioscience is much, much further ahead as far as scaffolding research and incorporate inquiry into the curriculum than physics is. So physics wanted to be in the program to sort of learn from bioscience as the transformation project evolved. So that's also a big component about motivation, that we know that bioscience is doing something good, but we didn't quite know what. So we wanted to get in that. So yeah, so that's my intro, I guess.
I'm going to jump in real fast and say I think it's funny because we are also participating with biology at our school, and they have had nothing but trouble getting their cliques together to come to an agreement. And so while I think they have some research going on and lots of peer mentor, we're actually, I think, a little ahead of them in terms of scaffolding it into the curriculum. So it's a little backwards from what we see at Rice.
And Beth and I were really intrigued when this project was had started, because there are very different programs and universities, as you can imagine. And so it was going to be very interesting when we were invited to go ahead and participate, just how the programs are just so vastly different, and yet in some ways also facing similar challenges with similar goals. And so and it's been really a wonderful experience to kind of learn a little bit about how each university has its own unique challenges and some of the proposed solutions. And so maybe in thinking about some of the proposed solutions, before we open it up to a general Q&A, is, we know a little bit about each of your motivations. Could you maybe give us some high level kind of overview of the activities that you've done during this time, and going ahead and thinking about and maybe trying out some type of the research activities within the curriculum, if that's okay? And so Lam, maybe I'll start with you at first, and then I'll go back to Brett. So again, just a high level stuff that we can dive deeper depending upon the interest of our audience here.
So broadly speaking, I guess there's been three different, I guess, way of attacking the problem that we chose to do. So the one is we introduced a research article reading class for freshmen. I mean, anybody could take it, but usually freshmen and sophomore take the class. So previous to that, there were no class that was offered that really let freshmen dive into the research that the physics faculty engage in. So the course is called Seminar in Physics and Astronomy Research at Rice. So what we do is we take an article that one of the physics faculty have published relatively recently, within the last 2 years. And then we have the student read through the paper. So the first paper we have them read was a Nature paper on superconductivity. So it's not an easy paper to digest. So it takes them about three weeks or so to go through, just to understand what the paper is about, not in detail. But so each week they assign a homework that go through each section of the paper. So the first one is just the title and the abstract, and that's all there is. And then the next one goes into methodology, basically methodology, because that's the next easiest part to understand once you sort of understand, what they're trying to do. And then finally, the last assignment is on sort of the analysis and conclusion. So that last assignment is meant to be extra challenging. So usually it takes students maybe 4 or 5 hours to complete the last assignment. But but by that point, they are prepared to tackle that, because they already understand sort of all the peripheral stuff that is required to understand, what the paper is trying to do and accomplish. So we've done this. Yeah. So that's the one front, and then the other front is we introduced this paradigm, I guess, because we already have undergraduate research for our undergraduate. So we introduced this paradigm called vertically integrated projects. So this is an idea that comes from engineering. So the idea is, instead of getting individual students involved in specific project, we have a more broader project where we get a cohort of students to start in their freshman year if possible. And then that project would grow over time. So as the student progress from freshman to sophomore year, and we recruit more students into that research project, then the student from the previous year take on a heavier leadership role, and then they would help the other student along, so the project is meant to be organic, and it grows from small to large as time progresses. And then the third component is we have started to create these what we call inquiry-based assignment modules. So each assignment, they are meant to be done between like 2 to 4 hours, and they encapsulate one or maybe two facets of inquiry, like framing, methodology, analysis, and presentation. So the student do these assignments, and they're all open-ended. So there's not like a calculation they have to do to get to the answers. So so we created a set of these assignments for the freshman sequence of class, and we're working on the sophomore and junior level. So that's the 3 fronts of attack that we have engaged in since we started the transformation project.
Great. So Brett, same kind of question. It's just that overview of some of the activities, and then we'll open it up for some questions.
Okay, so I think the first thing we felt we had to do, we were kind of in the sort of midst of we wanted to revise our curriculum anyway before we started this project. We felt there were some holes missing and some other things that were missing, so this fell in line right at the right time. So we wanted to get some official sort of what's our learning outcomes really that we want from students when they go away, right? We have these course outcomes that those are hiding inside the courses. How do we connect those together? Well, at the end of the day, when they graduate and they walk across the stage, we want to be able to say they know these things about content, but also what skills have they learned in the research area? So we decided to formally adopt the Aapt Lab Guidelines as our research side of the learning outcomes. And so if you haven't looked at that document, you can look at those, but there are 6 basic areas where they want to get those skills. And so we adopted those. So while we were revising the curriculum, we went through, and each faculty member went through each course and said, all right, am I hitting any of these in my courses? And so we basically made a big curriculum map that said, oh, wow, we're doing these 3 things really well. And wow, we don't touch this at all. We need to go back and fix that. So we went through and started trying to fill in those holes in the research side of the learning outcomes. I think we found basically at the intermediate classes, we were doing quite a lot of stuff that was already being implemented. And it was meeting a lot of those learning outcomes that we were hoping to get sort of in the intermediate level. So we decided to go backwards and start then with the introductory courses, because that's one where our focus was on the retention and recruitment side of things. And it got a lab in it, so we felt like it was an easy place to sort of adapt to those things. So we started doing there, and the first thing we did is in the first semester, we implemented this 3-week open-ended project. So we designed a fan cart that's programmable by an Arduino. It's got 2 fans on it, one forward and one reverse. And what the students are given is basically this fan cart and a track, and they're allowed to use any sensors they can find in the lab or whatever they want to use. And then they have basically these 3 weeks to sort of build a model of what the cart acts like under these different fan motions and that sort of thing. And then in week 3, they're given a distance somewhere on the track, and we actually give them 2 distances. We give them a short distance, where the backwards fan doesn't play as much of a role and you have to watch that front fan so it doesn't get going too fast. So see if their model can handle that short distance and then a longer distance as well. And they're given about 10 minutes to take the model they've developed after making all these measurements and building this model up to turn it into a model that they can plug in some numbers and go, oh, I'm supposed to get 1.8 meters. How do I program the fans to make that happen? And so that's the big sort of open-ended lab that we added there. So we had that 3-week process basically in that intro lab. We've done some sort of modifying and revision of projects that we've been doing at the introductory level. And I think our big issue right now in terms of implementation is sort of the upper level skills of like constructing knowledge and communicating physics yet. We have some issues where we're covering those formally in the coursework. And we're going to try to do those more of the upper level, but we have a new sort of capstone physics lab course that we got equipment for. And then COVID happened, so it hasn't run fully yet once, even though it's been available for 2 years. So that one's been a kind of a pain. And we have some upper level astronomy courses that are sort of in the same boat. They haven't had a lot of opportunity to sort of see how that is going to pair out and see if it's working. I think in the look ahead, what we need to do now is we also just underwent a big general education revision that's very different than what we had before. So we've had to make some changes to our lower level courses to meet those demands. And it's time to go back and sort of look at those learning outcomes in that curriculum map and see if the revisions and stuff are filling the holes that we intended to fill, and that we haven't opened up new ones. So I think that's sort of where we are at the moment.
Great, thank you. And with that, I'd like to open it up for questions. And if there are no questions, that's okay. I have a series of questions that I can ask.
So I have a question for Lam. Andrew Young here. My question for you is, you mentioned that you have your older students sort of mentor your younger students, but do you just sort of drop your older students off in the deep end and say, you're now a leader, so go lead? Or do you provide them some information or some guidance on how to be a mentor or be a leader?
So the original idea is that the students who start out as freshmen in the research group will get some training both with the faculty, also with leadership training from there's a leadership institute at Rice that is from John Dewar. He's some billionaire that worked that got a bunch of money working as a venture capitalist. So his big things is like this. Anyway, he had this leadership institute at Rice. So that was the original idea, that the student will get both training from their faculty mentor and also training through the leadership institute. But like Brett, unfortunately, like COVID hit, so like we didn't really get to actually execute that program. So like there were a couple of like vertically integrated projects that got started, but then it sort of got interrupted because COVID. So like we just have to sort of pick everything up, hopefully this next year. So, but the original idea is that they will get some kind of leadership training as well.
Okay, thank you.
And in fact, Andrew, just to let you know, one of the we were talking with the faculty member who was in this project, and he was lamenting in a way, what COVID did, because in a way it broke up the sequence. So now he'll have to go ahead and start kind of that process over again and build up that cohort of students. But to date, he's been very pleased with how it's been working quite well. Any other questions? Yes, Mark.
So I have a question that kind of fits a larger theme of things I like to think about. But as we ask our undergraduates to do more authentic research and get into research projects and get involved, we obviously have skills that we're looking for them to develop. And there's that large skill progression that occurs from course to course to course, that whole curriculum map that you've filled out. I mean, there's a plan. But as part of that plan, I'm curious, is there any explicit training that, or do you see growth in students that there's a transition from them seeing themselves as I am a student doing a lab project to eventually becoming I am a researcher at, or I am a budding future young investigator? Like there's an important transition that occurs there from being a student novice to being a confident investigator. Is there anything that's specifically built into the system that addresses that type of kind of self-actualization of the student?
So I think maybe I can address that at least in part. So one of the things that we've been doing is trying to make sure that that does happen, right? So that they see themselves as an actual researcher and not just, oh, I have this prescription I'm supposed to go do in the intro lab. So one of the things we've been doing in our intermediate levels is the students actually have to, with faculty guidance, right, propose research projects. So in our thermo class, we had an open-ended one that was a little crazy and just people did a lot of different things. But this last time it was offered in this previous fall, the faculty member came in with basically an idea. So Stephen Chu said a few years ago, like, what if we painted all the blacktop parking lots white? Would that help reduce, heat island effects? And so that sort of came up in the start of class, and and instructor said, this is something we could do. I've been given permission from facilities. We can go over and paint some of the parking lot over here that's not being used because there's not many students on campus right now. And we could do the project if you guys want to do it, but you're going to have to figure out, here's this broad question, but how are you going to measure this and how are you going to implement it? So they actually had to sort of sit down and think through, how can we measure the temperatures at a regular intervals and get that data back and other things. The previous group had in the same class, but in the previous semester, they decided to do something on energy efficiency. We've been working with our green part of the campus, and we were getting a new building renovated, and they were talking about the LEED certifications and all that stuff. And so they said, could we go around campus and just make some measurements from different buildings and try to determine, along with some numbers from facilities about energy usage, could we do this? Is this something we could do in this class as a project? And the faculty member was like, yeah, sure, go. Here's all the, here's a small budget that you have to get some equipment, usually Arduinos and temperature sensors and temperature probes. And here's a contact with facilities. Go make a model, a simple model, and see if you can do that. So that's sort of a class that everybody takes. I know one of Mike's favorite projects that we do is we have a biannual trip to Barrow, which is not Barrow anymore, but I can't say the Inuit name, Alaska, where there was initially just a faculty member just doing some geophysics studies of ice up there and looking at the ice shelf near the shore. And it's developed into a whole class sequence now where the students have in this fall, these upcoming students in the fall will propose a research project that they're going to do while they're up there. And then they get approval from the faculty member and they start getting their equipment together and putting the system together. In the spring, during spring break, they'll actually go on the trips. They'll have a little bit of lead time to make any final adjustments and do any testing before they head all the way to Alaska. And then they'll go up there and they run. And it always fails, right? Something always breaks when you're there. Stuff at -40 doesn't always work the way you think it's going to. So when they get up there, they have to do some troubleshooting, right? And then they all come back and they all have to present their results too. So it's a nice sort of project. It is a little more expensive for them because we can't pay for them all to fly to Alaska, but we have been able to supplement it with some foundation funds. So I think we're trying to address that transition because it is an important transition where they're just, here, follow this rote kind of lab. And even in the open-ended lab we do in the intro class is kind of rote, right? They only have so many measurements they can make. But this is a little more open-ended, and it does require them to sort of think ahead and plan out that process and how they're going to make the equipment, design the equipment, get the data, and do all that stuff.
I had a question, and the question was that how closely does your undergraduate research tie to whatever the specialties of your faculty are?
Well, for Weiss, I think is is very much tied to the specialty of the faculty. I mean, that is sort of one thing that I think that our faculty needs a little bit of training on differentiating research that are meant for graduate students and research that are meant for undergraduate, that the point of the undergraduate research should be to educate the undergraduate on how to do research and like, you know, and just train them to become researcher, as opposed to the end is something that the faculty want to, you know, to have done so that a graduate student and postdoc could take it and use it. So I think that speaks to in some way a larger issue with like our department, in that for most part, our students who does research with our faculty are very successful. I mean, they publish paper in PRL, in, you know, Science, Nature, so if you simply look at that metric, then, you know, then we're very successful with our undergraduate. But the question is to ask is, what about all the undergraduate that are not doing research with our faculty, or that started but did not finish? So I think that speaks to a more inclusiveness and diversity issue, but it's a little hard to move that dial, because culturally, how do you convince people that, you know, have undergraduate that have published in top rated journal to say that maybe you should have also, you know, lower level project for, you know, other undergraduate that might not be the, you know, the top level student that you've been getting. So
I think this is an indication of the differences between Rice and Radford, in that for the most part, the research our students are doing are not generally tied to what we were trained to do. So I and the faculty member who now does the geophysics project locally and also in Barrow are both do semi-classical general relativity, which is not something you're generally going to do with a student. We do have an astronomer who obviously her students are doing stuff that are tied directly to her research. But we have a high energy particle physicist, and we have no research program here. He doesn't have access or anything. In fact, he's retiring this next year. So the research we're doing with students is not necessarily directly aligned with our own research interests. In some ways, we've had to, I think, fall back on that curiosity we have as physicists and go, you know, I don't know what this is like, but let's go mess with it, right? And play around and see if you can learn something yourself while you're doing it.
And I'd just like to add that, you know, when I have conversations sometimes with faculty as well, you know, we talk about, you know, how to integrate undergraduate students into research. And one of the chairs at my institution said something that caught my interest, is that he also mentioned, he said, in addition to that, you know, and of course, my goal may be to go ahead and have these projects where they're getting a foundation in research skills and developing those skills with ideally a goal towards a final product that's disseminated through some type of peer-reviewed journal. He said, but I also think about this as an opportunity for research training. And I'm bringing the students into that with that kind of mindset. How am I helping them trained to be researchers, to ask the question, to decide what the procedures could be? How do I go ahead and approach those types of problems? And that can build throughout the course sequence. So whenever he was thinking about certain courses and those, you know, what he was going to be doing in those courses, he kept that in the back of his mind. And I thought that was a very insightful way of thinking about how to integrate students into this kind of experience.
So, Gary, do you have a question?
Yeah, sort of maybe one of them may already been answered slightly, but sort of maybe two parts to it. My interest in this is that we've recently been funded to introduce vertically integrated projects into a large for our standards omnibus program with an intake of about 300 students per annum. covering majors, everything from, maths through physics, chemistry, biology, human biology subjects. And part of the reason behind it, the motivation, is that it's quite difficult maybe to get these students to see where they're going. And the idea, I think, seems to be to run sort of very, very much cross-disciplinary groups of students. So I'm wondering, does anybody have maybe experience with that? That you could have a biologist, mathematics student major, physics major or something, chemistry major in the one group. And the other thing as well, I think maybe I may have already answered part of it. What profile of students generally does this suit? Is it adaptable across the full spectrum of students, or is it does just tend to be something for the more able students?
So for the vertical integrated project, like I said, the original idea came from engineering. So from Georgia Tech, I think, is what the institution that really started it. So in over in engineering, the whole idea is based on interdisciplinary groups. So you want to have your group that have mechanical engineer, electrical engineer, computer scientists to be all together in one project. But I found that to be more challenging when you shift to the natural science, because there's some project, but for a project that faculties are interested in, there are often not that kind of overlap between different schools in this different department in the School of Natural Science. So yeah, I think it would be really good to have projects that really incorporate across different natural science disciplines, because that's how the world really is in a lot of cases, other than in academia, which tend to be more silo. So, and as to your second question, I think again the basic idea for vertically integrated project is that it should be more inclusive, in that you're not just trying to get the best students. You, like in engineering, I think they want a large cohort to start, where they that they could have synergy between each other, especially when you have interdisciplinary projects. So like a mechanical engineer might not know how to wire up the motor, whereas a electrical engineer would have that expertise through their classes. So the idea is that you have, start with a large cohort and, have them all work together on the first part of the project, and then see where that project grow. And then you kind of split them off if that's the organic way to go, that like there might be a side project that one small group might attack, and then there might be the core project that another group continue on. So one of the sort of, I guess, beauty of the vertically integrated project that I did not appreciate initially is how flexible it is. So yeah.
And while we're not doing these vertically integrated projects, because we don't have the same sort of research demands that Rice has, we do tend to be a little more flexible. So we had multiple projects. The trip to Barrow actually inspired some biologists to go up in the summertime and do some more. So my faculty member did some geophysics work in the summer there, not looking at ice then, but they were interested in developing equipment to monitor for nesting birds that move up there in the winter. And they couldn't develop the temperature profiles because the nests have to stay the right temperature, and there's permafrost, and what do you do with all this stuff? So how do they measure it? So they actually involved both biologists and physicists to make those measurements, and that has actually prospered into a number of projects that faculty members are doing across the disciplines. So it's been pretty nice.
Cindy?
Great, thank you. Cindy?
Yeah, hi. So We're actually very lucky at Vassar in that we've always been able to get students involved in research because every faculty member gets a research assistant every year. So we've always been able to do that, but that was kind of never part of the curriculum. We've also been lucky in the fact that 3 years ago, Vassar implemented a new teaching policy where each faculty member teaches 4 regular courses and another course, which is called an intensive. And so Beth knows this. I've been bringing students to AAPT meetings, and they've been coming and getting intensive credit for it and produce documents and whatever. I've got a bunch of repeats, Beth, coming back this summer. 4 papers are being presented on research that was either affiliated with going to AAPT or something else. And so we've been very lucky, and it's not just me. I've been focused on the AAPT because it's so easy to take them to the virtual meetings. I think I've got 16 coming this summer now, but other faculty are doing intensives also. So for example, my colleague Juan did an intensive with 4 students where he focused on microfabrication technology. So whereas before those would have been like independent studies, now we actually get teaching credit for it. And so it's more like a course. And I did talk Juan, by the way, Beth, into giving a paper on this at the summer meeting. So anybody wants to hear about that. But then other faculty like Jenny Magnus, she might take, she does biophysics. So she might offer an intensive, on biophysics in her lab. So these students are getting to do more research through these intensives that we are now not only allowed to teach and get teaching credit for, but for the physics major, we've actually required, besides their 10 regular units, that they complete 1 unit of intensive credit. Now that could be 1 unit with 1 person, or it could be 2 halves and stuff like that. So we've been very lucky. It's been hard to kind of navigate how much we let the students pick what they, giving them choices as far as, I'm doing 17 of them this fall, which is way more than I should be doing. But, so how do we navigate that? That's been a bit of an issue. But the intensives are a place for students to be doing research, and that's connected usually to a faculty member. So it seems to be going okay.
Excellent.
I was going to say, I think broadly, one of the things that we're still working on and we haven't sort of finalized is exactly what you mentioned, Cindy, is that this workload, how do you manage this? So the faculty member who's doing the thermal projects, sorry, there's a big truck going by. The faculty who's doing the thermal projects is busy teaching basically 17 students in thermo, and they're doing this 1 project this last year, but they've done literally like 5 projects in previous years. So he's basically trying to do a regular course and sort of administer 5 independent studies at the same time. And we're trying to figure out a way to manage that workload without overwhelming people and burning people out. So I'd love to hear people's ideas for getting the administration on board.
We were very lucky in that, the faculty went to the dean and the president, et cetera, several years ago saying, we can't teach 5 classes a year. We wanted to go to 4 classes a year. And the compromise we got was 4 classes plus one of these intensive things, which you can make into anything you want. Now I'm overloaded, as I just said. I'm doing, more than I should this fall, but I'm basically going to play the game that the dean is making me play, which means he won't give me credit this year. So I'm just going to put some of the students who go to the AAPT this summer, they're going to actually get their credit for their intensive in the spring of 23. I hope the dean doesn't see this, but unfortunately, this is what our department's been forced to do, because I need to do this for the students, and yet he won't let me bank them. So I have to unfortunately play the game. But maybe, Brett, your faculty can start to see these things as valuable enough that you can start getting some sort of teaching credit for taking on a certain number of these or something like that.
Yeah, so we're playing the game, as Mike and I were talking about this last week with Beth as well. I have these sort of informal agreements with the dean that are not formalized, that we've gone through and changed workloads. We've been working on a formalized document, but we haven't had the same provost for longer than, I don't know, a year and a half. We just keep going through provost like they're change underwear. And our president's moving, so we've had a lot of churn, and it's very hard to manage and getting something like that through at the moment. And then the gen ed is changing, and I don't know when we're going to be able to really do this. So I'm counting on sort of playing this game with the dean to get this done internally without anybody else knowing.
That's why Mark's not going to share this with any of them.
My dean knows, so it won't matter. And he's moving to temporary provost next year, so interim provost. So for a while, I'll be safe.
Any other questions? And if not, I have a question. Yes, Mark.
So one of the questions that high school teachers face around this same larger topic is the balance between kind of teaching your traditional course and covering the material that you've always covered, and then adding in research opportunities on top of that. And as we're on this theme of overloading and workload and the idea of teaching a regular course and managing this, in any of your discussions, have you asked the question, is it reasonable to reduce the kind of standard course material in favor of both increasing the amount of work, the amount of access for students to have into research, but also practically solving this issue of doing too many things at once?
So this is something we've been approaching as well. So one of the things we'd done before we actually started CUR is we'd been trying to add some computational activities to the introductory sequence to sort of get them out of, it's not just, kinematics and that's all we're ever going to do, right? So how do we add in air resistance, which everybody likes to skip? So when we did this 3-week project, this open-ended project in our lab, we literally had to remove 2 labs. And some of those labs were people's favorites, but you got to take something out. We went through our second semester sequence and actually pulled all of the thermo out completely from that class. We knew our majors would see it again when they took the thermo class, and pretty much everybody else had taken chemistry and we're seeing it at some level anyway in their chemistry classes. So we just yanked it out. And you have to be, I think, willing to do that and go through and go, can I take this stuff out and still be okay somewhere else? They'll see it again. Or is this really that important? Or is the research skills more important? So I think you do have to play this balance, because you can't drive the students into the ground, just like you can't drive the faculty into the ground. There's only so much time that we had.
So I guess I could speak a bit about in the intro physics course, how we sort of incorporate the inquiry-based problems. So changing the core curriculum is very difficult at my institution. So what I have done to introduce these open-ended questions to the student is I made it basically an extra credit. So a student could do one of these assignments, and they get sort of a scale of 1 to 3. So it's just 0, 1, 2, 3. And then based on that number, they get a bump on the lowest, I guess, quiz grade that they have that semester. So it doesn't worth a great deal, but to them it seems to be enough motivation for them to complete the assignment. So it's all voluntary, but usually I get about, I only done it 1 semester, but I got about 50% of the student did complete the assignment, and most of them completed, did quite well on it. So this how I sort of got around with like not being able to really change the core of it, but still be able to expose students to that more open-ended type of question. And the students really do enjoy doing open-ended question. I think like that's a common, like we do a survey for the student, and that is something that almost every student say, like, I really enjoy the open-ended nature of the problem. Of course, there's a flip side. Students also say that while I like the open-ended nature, I also didn't like how vague the instruction was. So you can't really win. So.
Great, thank you. Drew, you have a question?
I was gonna comment actually.
Okay.
You know, we've also talked about, you know, adding more computer stuff to the internal classes, and you know, it always ends up being, well, how much time can you afford to take away from the topics? Do the faculty that are going to teach the class actually, are they good enough with computer stuff themselves? I mean, for example, I don't know any Python. You know, I'm old. I still use Fortran when I want to code something, to be honest. All right, works, you know, but doesn't help my students much, right? You know, I'm currently grading statistical mechanics things, and they're giving me Jupyter notebooks, and I have to tell them, I don't know how to run that. You have to actually send me the answers. I'm not running your code for you, kind of thing, right? But you know, we have the same discussion all the time, and in the courses, say the engineers would take, as Lam was just saying, there's no way we can change the curriculum. I mean, there's accreditation boards in engineering. You're not touching any of that. The courses for our physics majors, we can certainly tweak. University is never going to know. That's not going to be a problem. But getting all the faculty to agree on what we could maybe slightly remove, because inevitably someone's going to say, well, you didn't cover that in mechanics? How do you expect me to teach blank, right? I mean, that happens regularly. And so it's not easy to put some of this stuff in. I mean, we've always had a research requirement, at least for say 15 years. So everyone has to do one semester of research to graduate. And that varies from students who start as sophomores and end up perhaps with a name on a paper, maybe not, or to others who are, okay, it's January 10th. I need to do some research to graduate. What do I do? I'm like, well, you should have started talking to faculty about 8 weeks ago is what you should have done. But let's see, you know, what do you think you're interested in doing? And when do I send you to this guy's door? So there's a big range of what they end up doing, but they've always had at least one semester required. So that's sort of where we are. But we're also thinking about curriculum changes, but it's going to be a very hard fight, to say the least.
And I should mention that University of Arizona is one of the institutions that's participating on this project in other
really?
disciplines, but in other
Okay.
disciplines,
Yeah.
disciplines.
Okay.
Any other questions?
Beth, I think.
Yeah, I have to go.
Yes, Beth?
So yeah, I have a 5 o'clock meeting. So take care, everybody. Thanks, Lam. Thanks, Brett. And thanks, Mike. It's been a real privilege working with this group on this project. And I hope everybody got a chance to hear the wonderful work that Lam and Rice is doing and Brett and Radford is doing. It's been a lot of fun. So see you. Take care.
Bye-bye.
Yeah, and I think that's a good way to kind of wrap it up. You know, this project is still ongoing. There'll be another year of the project that's there. And one of the things that we're both kind of encouraging Lam, Brett, and their colleagues to do is to kind of write up some of their findings and just observations about what some of their challenges were, what some of their successes have been, what some strategies they've used in order to kind of facilitate conversations, to make headway in certain areas, recognizing, just like Drew mentioned, there's sometimes it's just almost insurmountable challenges. So if I can't move this mass right here, is there a way that I can maybe supplement other things that we're doing in order to kind of at least get to where we'd like to go? And so there's a lot of very unique things that they're doing, some similar and some very distinct, because they're very distinct institutions. So we're looking forward to, and as we keep telling them, we're looking forward to what's being, what they're doing and how they're going to disseminate it. But this really has been just an outstanding project, to where Beth and I just learned a great deal just by watching two fantastic departments and a lot of very energetic faculty get involved in this. And I would like to thank both Lam and Brett for all of their hard work on this project. They've done an excellent job in leading their respective efforts, and their colleagues have just done a wonderful job with helping out with this process. And I think with that, I'd just like to thank everyone for coming this evening. It was great to have you here and to participate in this hour of coffee talk here. And thank you very much. And we hope that all of you wrap up your semesters well, and that it's that summer is looking up.
So
Okay,
thanks for joining us, and we'll be back again 2 weeks from tonight at the later time slot, 7 p.m. Eastern.
Thank you.
Bye.
Thank you.
Thank you.
Thank you guys. Take care.
Thanks. Bye.